Welcome students. Now we are going to see chapter 1 real numbers in Cbse 10th standard mathematics. So for the students of a Central Board of School Examination 10th standard, we are going to see chapter 1 real numbers. In chapter 1 real numbers, the first topic that we encounter or that we come across is Euclid's division lemma. Euclid's division lemma. So before going into Euclid's division lemma, let us try to understand what is the meaning of lemma, of the word lemma. Lemma is generally minor proven proposition which is used as a stepping stone to prove a larger result. So what is a lemma? Lemma is a proven statement. Lemma is a proven statement which is usually a minor statement. Of course, it is not necessarily a minor one, because in mathematics there are beautiful lemmas are there which are of most important, which are as good as any other theorem. But in general, in mathematics, any minor proven proposition is usually called as lemma. So what we have to understand from by the word lemma is it is a proven statement. So that is enough for our understanding. So now we move on to Euclid's division lemma. So what is Euclid's division lemma? Now we are going to see the statement. Before writing down the statement of Euclid's division lemma, we all know about division. We all know about division. What is that? Division. So for example, let us consider 17. So what will happen when you divide 17? When you divide 17 by 5, what you will get? You will get, it will go 3 times. So there are 3 5s are there in 17. So total is 15. And what you will get is, this is what is the remainder. So here, what do we do here is, this number 17 which is to be divided by 5 is what is called dividend. Dividend. So what the number that is to be divided is dividend. The number which divides, so this number, so 5 is the number which divides 17 is what is called divisor. So this number 5 is called divisor. And how many 5s are there in 17? That number is what is called quotient. That number is what is called quotient. Okay? And what is remaining? So is what is called a remainder. What is called remainder? Okay? This is what is called remainder. Now, if you carefully look at this, what will happen? You can write 17. You can write 17 as 5 times 3. 5 times 3 plus 2. You can write like this. That is, what is 17? Dividend. So 17 is nothing but dividend. So dividend is equal to what is 5? Divisor. So divisor times quotient. Divisor times quotient plus remainder. So this is an important result. So dividend is equal to divisor times quotient plus remainder. This is what we call it as This is what we call it as Euclid's division lemma. This is what we call it as Euclid's division lemma. So this is what is called Euclid's division lemma. And see, boys, we have to make a note here. We have to make an important note here. What is that? What is that? See, I have put 17 here. What would have happened if I put what would have happened if I put 15? If I put 15 here, what would have happened? Had we divided it by 5, we would have got 3 as the quotient, and remainder is going to be 0. What would have happened if I put 16 in place of 15, and if I continue to divide it by 5, again I would have got 3 as the quotient, and my remainder is going to be 1. What will happen? So we have put 17. Now let me put 18 here. Let me put 18 here. Why I am doing this? We are going to witness an important point. Let us again divide this by 5. Again we will have 3 as the quotient, and the remainder is going to be 3. Okay, in this case. Now what will happen if I put 19? If I put 19, again if we divide it by 5, we will get 3 times, and the remainder is going to be 4. Now if I put 20, what will happen? If we divide it by 5, we will get 4. Remainder we are going to get 2. Now in every case, see, look here. If it is 15, remainder is 0. If it is 16, remainder is 1. And if it is 17, remainder is 2 here. If it is 18, remainder is 3. If it is 18, remainder is 3. Okay? If it is 18, remainder is 3. If it is 19, remainder is 4. If it is 20, remainder is 0 again. Now, when you look at the remainder in each case, so remainder 0 is less than the divisor. In this case, when 16, remainder is 1, which is again less than the divisor. When it is 17, remainder is 2, which is again less than 5, namely the divisor. So when the number is 18, the remainder is 3, which is again less than what? The divisor, namely 5. When it is 19, remainder is 4, 4 is less than 5. So in all the cases, we observe that this remainder is always less than the divisor. So what are we going to do now? We are going to make a statement now. We are going to write a condition on the remainder. We are going to write out a condition on the remainder. What condition? Comma, what condition we are going to write? 0 is less than or equal to remainder. 0 is less than or equal to remainder, which is strictly less than divisor. So this is the condition that we have to remember about the remainder. So what is the condition on the remainder? Condition on the remainder is, this is the condition on the remainder: 0 less than or equal to remainder less than divisor. Now this is what we call it as, this statement, dividends equal to divisor times quotient plus remainder together with this condition. Is what is called Euclid's division lemma. This condition is what is called Euclid's division lemma. Okay, so what you have to remember? You have to remember this statement. Now we are going to write this in terms of symbols, because instead of writing with the words, we are going to write down this using symbols. Now we make a formal statement about what? Euclid's division lemma. Euclid's division lemma. Okay, we are going to make a formal statement about. So division, we all know that division, we usually make use of division with the integers only. So we are going to make a statement about Euclid's division lemma about integers. So what we are going to do is, let us consider, let a and b, a and b be any two positive integers, any two positive integers. You can take any two positive integers. You can take any two positive integers. A and b be any two positive integers. Then there exists unique integers. There exist unique integers. Q, let us call that as quotient. Okay, Q is quotient. Let us call it as quotient. Let us Q and R. What is R? R is remainder. Let us call it as what? Remainder. Two integers satisfying. They satisfy this condition. Satisfying. Now here A is the dividend. A is equal to B times Q plus R, where R is the remainder. What is the condition on R? As we said earlier, 0 is less than or equal to R, but it should be less than the divisor. Who is the divisor here? B is the divisor. Now for your understanding, let me write this B is what is called, let us take that B to be our divisor. Of the two integers, positive integers, let us take B to be our divisor, and let us take this A to be our dividend. Let us take this A to be our dividend. So whenever we are given two integers, positive integers A and B, it is always possible to find unique integers. Two integers Q, namely quotient and R, remainder, such that satisfying quotient and remainder, satisfying the condition. What is the condition? A is equal to BQ plus R. Now what is important is the condition on the remainder is important. The condition on the remainder, namely the remainder can be 0 or it is greater than 0, but is always less than the divisor. But this remainder is always less than the divisor, as we have said in the little while ago. See, if you look here, this is what dividend is equal to divisor times quotient plus remainder. The condition on the remainder is 0 less than or equal to remainder less than divisor. This statement only we have rewritten with symbols like this. So this is what is called Euclid's division algorithm. This is what is called Euclid's division algorithm. This you have to remember. This is what we call it as Euclid's division algorithm. Everybody has to remember. Now you may wonder why this Euclid division lemma is so important. Now using division lemma, Euclid's division lemma, we can answer few problems in an easier way, and we are going to find application of this division lemma in our next lesson. Now we have said that we can find unique integers. Now let us try to understand what do we mean by unique. For example, as in the previous case, if we take 17 if we take 17, then if you divide it by 5, 5 is your divisor, then how many times you can, how many 5s are there? 3 5s are there. Then what is the total? This is 15. So what you will get is 2. And remember that 2 is definitely greater than 0 and is less than what? This divisor 5. And what do we mean by unique? Now we are going to explain that. See, whenever we are given 17 as our A, if A is 17 and your divisor B is 5, then you can find only these two integers 3 and 2. No other number can come here. So that 17 is equal to 5 times 3 plus 2. Other than this, you cannot have this relation for, you cannot find other than, here there are, you have to find two integers other than 3 and 2. You cannot find any other integer other than 3 and 2 satisfying this condition. That means the existence of 3 and 2 are unique. The existence of 3 and 2 are unique. So existence of 3 and 2 are unique. That means if your dividend is 17 and your divisor is 5, then your Q must be 3 and R must be 2. And if you want, you can justify with another example. For example, let us take here, let us do one more example here. If you suppose, if our number is 18, our dividend is 18 and the divisor is 5, then the quotient is going to be 3 and the remainder is going to be 3. So in this case, this 3 and this 3, this pair is going to be unique. So they are unique integers satisfying this condition. Meaning you cannot, whenever your dividend is 18 and your divisor is 5, you cannot have a relation like this with any other number other than 3 and 3. You cannot have. That is what uniqueness says. That is what this uniqueness says. Okay, with that we stop here. With that we stop here, and we will do the application of a division algorithm in the next class. So before leaving, again I remind you about Euclid's division lemma. What is division lemma? Dividend is equal to divisor times quotient plus remainder. What is the condition on the remainder? 0 is less than or equal to remainder and strictly less than divisor. In symbols, suppose if you want to write that in symbols, whenever A and B are any two positive integers, then we can always find two integers Q and R uniquely such that A is equal to B times Q plus R, and the condition on R is 0 less than or equal to R less than B. That uniqueness is whenever your dividend is 17 and your divisor is 3, you cannot write this statement 17 is equal to 5 times 3 plus 2. This is the only way that you can write 17 as combination of 3 and 2. So no other number can satisfy this relation no other number other than 3 comma 2 can satisfy this relation. Likewise, if your number is 18, then your dividend is 18 and your divisor is 5, then your quotient must be 3 and your remainder must be 3. They are unique. No other number can satisfy this relation or this equation. Okay, so that is what is Euclid's division lemma. With that we stop here. In the next video we will find interesting applications of Euclid's division lemma and how it can be used to some of the results or some of the it can be used to understand some of the natural numbers or list some of the natural numbers in the next video. Thank you.